Alright, today we'll be talking about trig identities, which are the basic fundamentals of trig. Trig identities are like to trig what factoring is to algebra. They're not essential, but they definitely make computation and calculations a lot easier. Okay, so trig identities, very cool. Here's some basic identities right over here. These are called the reciprocal identities, these 6 right here. And basically, that just means that the sine is reciprocal of cosecant, cosine is a reciprocal of secant, tangent is reciprocal of cotangent, and vice versa. Okay, so that this is just verifying everything. Now, the really cool thing about this is, okay, let's say we want to test it out on a calculator. For example, the cosine and the cotangent. Okay, well, not the cotangent, the secant. Okay. So we want to check to see if cosine of 30 is the same as secant of 30. Now obviously those aren't going to be the same because they're not equal to each other. But if I put 1 divided by secant of 30, voila, I see that they're actually going to be equivalent. And the cool thing is that all of these identities that you use will be true for every angle that you plug into them. Okay, so for example, if I plug in 60, okay, and then I plug in 60 here, voila, I get the same answer. So the reciprocal identities are amazing. All of the identities are amazing because they're a certain type of trig equation that when you plug in angles, you're going to get the same value on both sides. And it's an amazing thing to work with, okay? Now, this is these two right here that lead into it. The tangent and cotangent one. These are reciprocal identities, but just in the fact of tangent and cotangent being written in terms of sine and cosine. Okay, so it's really kind of cool how you set it up. I mean, it just totally makes sense in just how it is. So if you ever see tangent, just think of sine divided by cosine, and cotangent, just think of cosine divided by sine. You can easily transfer it. Now these ones right up here are the Pythagorean identities. Okay. Right? And the Pythagorean identities are really quite amazing. Oh, shoot. I should define this more commonly known as the quotient identities. Okay, the Pythagorean identities, they're derived from the Pythagorean theorem. Okay, and this one right here. Now, in pre-calculus and trigonometry, you'll actually learn how these are derived. But for right now, we're just going to accept these guys as fact. Okay, now can you rearrange these to look a different way and still use the identity? Yes, as soon as identity is verified, and you'll learn how to verify identities in this chapter, you can actually rearrange it so you can manipulate other identities to look just like it. So for example, sine squared of theta is equal to 1 minus cosine squared of theta. You could definitely replace, if you ever see in the future, if you see 1 minus cosine squared of theta, you can replace that with the sine squared of theta. It's pretty simple. Why? Because I minus this from both sides. Okay, and it's just as simple as that. Now, that does lead me to the next part. What does this cosine squared of theta mean? Well, cosine squared, and this goes for all the identities, cosine squared just means that you are squaring cosine of theta, and for some reason they just wrote it like this. It just makes a lot more sense to write it like that, and it's actually a lot faster to represent it that way. Okay, and plus you're not getting confused, you're not accidentally squaring the theta, which is the angle that you're working with. Okay, now let's go over some actual identities. Okay, now here's a gorgeous one right here. This is sine of theta times tangent of theta, and we are allowed to, because this is an identity, rewrite it as secant of theta minus cosine of theta. Now you're probably asking yourself, how do we go from a times situation, a multiplication problem, to a subtraction problem? That seems impossible. What trigonometry is not. Okay. Now, first off, you want to pick the more complicated side and rewrite it as the other side, or rewrite it so that it looks like the other side. That's how verifying an identity works. So, just for a challenge, we're going to rewrite this side because this has an operation in between. Now, to start off, you're probably going, oh man, I don't even know where to start off. Well, start by writing in terms of sine and cosine. So, secant is actually 1 over cosine of theta. We do know that. And then we minus the cosine of theta. That's already in terms of sine and cosine. Okay. All right, now that may get you stumped, but think of this as two fractions. This is cosine over 1 being subtracted from 1 over cosine. I need a common denominator. Okay, so let's do the equal sign. We'll do the equal sign again. Okay, so the common denominator between cosine and 1 is cosine, so this is cosine of theta. And I'm going to multiply top and bottom by cosine of theta. Okay, all right. Now that I have them both with the denominator of cosine, I'm going to go ahead and subtract the top. So the top, I'm going to have 1 minus cosine squared of theta divided by cosine of theta. Okay, now if you notice, that's not getting to look anything like this, and this is where the rough part really comes into play. You're like, oh, I'm not a fan of this. Okay, but if you remember back up here, we had an identity that we wrote out that was kind of a manipulation of an original Pythagorean identity. And if you notice, 1 minus cosine squared is the same as this one, so I'm allowed to replace this into here, and that's the beauty about identities and the basic identities, that you're absolutely allowed to do this. Okay, so oops. So it's going to be sine squared theta, and it's going to be divided by cosine of theta. Okay, now I'm getting a lot closer than what you might think. All right, I'm going to separate this into two sine of thetas. So that's sine of theta times sine of theta. Okay, now here's the cool thing. I'm going to use this identity down here because this is sine of theta divided by cosine of theta. So I'm going to replace that with tangent of theta. And guess what? Sine of theta times tangent of theta. That looks an awful lot like the beginning of what I had. Voila. I have verified this identity. And that's a beautiful thing about it. There's no hard rhyme reason of what to do for this stuff. Usually you want to take the most complicated sign, rewrite it in terms of sine and cosine, maybe add or subtract some fractions. Sometimes you might have to multiply top and bottom by a conjugate. I mean, there's a lot of tricks to do it, but this is just like a living, breathing puzzle that will help you later on. Now, here's the cool thing. Now that I've verified this identity is good from here on out. So if I ever see secant of theta minus cosine of theta, I can rewrite it as sine of theta times tangent of theta, or vice versa. Whatever I need to actually simplify something pretty easily. Okay. All right, now sometimes you might have to simplify an identity. For example, I want to turn this into, let me see, tangent would be sine of theta divided by cosine of theta. And I'll put this in parentheses. Okay, and then I'll times this by cosecant, which is 1 over, I believe that's sine, yeah, sine of theta. Okay, and then when I simplify, I'm going to find that these two are going to simplify to 1s. I'm just left with 1 over cosine of theta. And guess what? That is the same as secant of theta. Okay, and so I verified that this left side can actually turn into this right side pretty fast. Okay. All right. Now, sometimes they might just ask you to simplify, so you don't know where to go. But I guarantee you, if you start simplifying, getting in terms of sine and cosine, you'll be able to see where this stuff will actually go, and you'll go, oh, okay, that's where it's going. All right. Now, some really quick things. Let me see. Tangent is sine of theta divided by cosine of theta. And then cotangent of theta is cosine of theta divided by sine of theta. And we got minus the sine squared of theta. Okay, well, if you notice, these are just reciprocals of each other, and when we multiply reciprocals, we get 1. So 1 minus sine squared of theta. Okay. All right. But we're not done yet, because if we go back to the last page, if I minus sine squared from both sides, I get cosine squared of my Pythagorean identity. And guess what? This actually can be simplified even further. Cosine squared of theta. Okay. All right. And some people might just stop at this first step. It's totally up to you how you want to do it. But either way, both of them are actually simpler than this part right here. Once again, trig identities, not essential to trig, but they are essential if you want to make your job a lot easier. Okay? Well, they are essential, especially in proof making. If it wasn't for trig identities, a lot of these proofs in trig would be null and void. Okay? All right, that's it for working with trig identities. I'll talk to you later. Bye.